inverse functions are what we're talking about today, okay? Today I'm going to show you how to find an inverse function, and next week we'll talk about like what we need it for, how to use it, things like that, okay? So let's start here. I gave you a list of ordered pairs. It's a function. None of the x's repeat, okay? And what I want you to be able to do is give me the inverse of this function. You ready? This is the function. This is the inverse. How did I find the inverse of the function? I switched what? Oh, I switched the x and the y, okay? Now, at first you said switched it, and I understood what you meant, and you knew what you meant. I just needed you to be a little bit more specific, right? And so when I ask what, I don't know if you thought maybe I didn't hear you, so you were a little clearer, which is also good. But you also said switch x and y, okay? Which is perfect. It's exactly what I needed you to say, okay? So if I give you a list of ordered pairs, we switch x and y. Can it really be that easy? Yes, okay? Now, there are different types of problems that we find inverse functions to, right? What if I give you an equation? How do you think you would find an inverse function if I give you an equation? Well, how did I find it up here? Switched x and y. So how am I going to find it here? Switch x and y, right? I'm going to switch x and y. I'm going to say x equals 2y plus 6. Here's where it's a little different, okay? I switched x and y, and that's good. Is this how we write our equations normally? No. So when we're given an equation, not only do I have to switch x and y, but then I have to solve for y. That's perfect, okay? I switch x and y, and now I have to solve for y. What do I have to do in this problem to solve for y? Subtract what? Subtract 6, right? I want to isolate my y, so I want to leave that kind of alone, right? So I get x minus 6 equals 2y. And what's left to do to isolate my y? So I divide everything by 2. And I get y equals 1/2 x minus 3. So did I switch x and y? Did I isolate y? Yes, right? So this seems like it should be the answer. And did you notice I said it seems like it should be the answer? Okay, I really have one more step that's kind of a non-step, okay? Because I actually have to write my answer now. And it seems like it would be this, right? But there's a notation that I need you to know. Would you agree with me that this means what? It's a function, right? F of x means it's a function, correct? This means it's the inverse. That's a notation. This negative 1 is not an exponent. It's where we put exponents, right? But it's not acting as an exponent right now. It's acting as a notation, meaning inverse. We say f negative 1 of x. You okay with that? So really all I have left to do is come down here and write f negative 1 of x equals 1/2 x minus 3. Done. Does that make sense? Any questions so far? Yes, sir? I'm not excluding it so much as I am rewriting how I'm writing the y. Remember, y and f of x for us are the same. So instead of writing f of x, I'm writing this notation right here so that we know for sure that this is the inverse of what I started with. Does that make sense? Okay. What about this problem? Y equals 2/5 x squared minus 4. how do I find the inverse? Switch the x and the y. That's the start, right? So x equals 2/5 y squared minus 4. And now what do I need to do? Solve for y, right? I switch x and y. When it's an equation, I switch x and y and solve for y. Okay? So what do I need to do first to solve for y? Add 4, good. So x plus 4 equals 2/5 y squared. How do I get the 2/5 away from the y squared? So yeah, normally I would divide, right? But it's a fraction. Do we divide fractions? What do we do instead? Multiply by what? Do you remember what it's called? Close. If I'm going to divide by 2/5, that's the same thing as multiplying by 5/2, which is this reciprocal. Remember that? 5/2? Yes. Yeah. Okay. So here I have 5/2 times this whole side, so I'm really distributing that 5/2 to each term on that side, right? So I have 5/2 x. Well, it's 5/2 times 4. I would do 5 times 4 is 20, and then divide by 2. So 10, yes, equals y squared. Is the y isolated yet? No. How do I undo a square? Oh, square root. Okay. I'm about to try to trick you, just so you know. Okay? Are you going to let it happen? Possibly? Okay. Maybe we should start with maybe not. Okay, okay. So what's the square root of y squared? Y, I kind of agree with that. Kind of. What's the square root of 25? Kind of agree with that. Remember when we ask about square roots, we're saying what times itself equals 25? So I agree with you that 5 times 5 is 25, but what else times itself equals 25? What about negative 5? Isn't negative 5 times negative 5 also equal 25? So when we're taking the square root of something, we have to take into account the plus or minus, right? But not on the y side, on the other side. Okay? So plus or minus the square root of 5/2 x plus 10. Now, something interesting came up last period. They said, well, what if it was 5/2 x plus 9? Would we say that was 3? So I'm glad that you recognize that you would know the square root of 9, but we can only take the square root of something that's a factor inside. This is not a factor. This number, even if it was a 9, is not a factor because that would be something multiplied by everything in there, right? That would not be what's happening here. This is just a number, and I can't take the square root of part of the number. See what I'm saying? So even if this was a 9, it would say 5/2 x plus 9, and it would stay. Does that make sense? Okay. So am I done? Almost, right? Come over here and we write f negative 1 of x equals plus or minus the square root of 5/2 x plus 10. Good? Ready to go on? Yes, ma'am. Yep. I took it away by like acting on it. It's a square, so I did the inverse operation of that, which is square root. And as long as I do it to both sides, it's still okay. God bless you. Are you good? Are you good? Okay. Everybody ready to go on? I'm going to add something to this really quick because we've got to talk about it. When I have an equation and then a comma and then something like this, y is greater than or equal to 0, or y is less than or equal to 5, or something like that, that's just putting a restriction on my range. This part right here is just restricting my range, right? It's not acting on this equation at all, is it? Okay, so when I go to find my inverse, do I really even pay attention to this? No, I don't. Okay, so how do you find the inverse function? Yes, ma'am. X equals 1/2 y plus 3 cubed. And now what? Solve for y, right? What do I do first to solve for y? Oh, I don't want to do that. I mean, that's what some people want to do, and I can promise you this, it will make it 5,006% harder. Eventually, I'm going to do that, right? When this is isolated, I can definitely take the cube root, can't I? I got to get rid of this first, right? So how am I going to get rid of the fraction? By its reciprocal, so 2 over 1, right? If I multiply both sides by 2 over 1, it's the same as multiplying by 2, just like you said. So I get 2x equals y plus 3 cubed. How do you undo a cubed? Cube root, right? How do we undo a square? Square root. So how would we undo a cube? Cube root. So I cube root, like that, okay? So on the left-hand side, I get my cube root of 2x. And what happens on my right-hand side? What do I get? Y plus 3. When I cube root something being cubed, I just get that thing, right? So what do I have left to do to isolate y? Subtract 3. When I subtract 3 on both sides, I get cube root of 2x. Now I do need to make sure that my minus 3 is outside of my cube root, right? I don't need to get it too close to so it looks like it's inside, because it's not. And then am I done? What do I have left to do? Can I ask you a question real quick before we go on? When we cubed root both sides, how come we didn't put plus or minus? Tell me again, what's the cube root of 25? Sorry, what's the square root of 25? 5 and negative 5, right? Because 5 times 5 is 25, and negative 5 times negative 5 is 25, right? What's the cube root of 8? So what times what equals 8? 2, right? Is it 2 and negative 2? Because negative 2 times negative 2 times negative 2 is actually negative 8, isn't it? So when am I going to know when to use a plus or minus and when not to? So square root I used it, cube root I didn't, right? What about a fourth root? I will use it. What about a fifth root? No. Sixth root? Seventh? So odds and evens, right? Even roots, I will have the square root. Odd roots, I will not. Okay? So what's left? Correct notation, right? F negative 1 of x equals the cube root of 2x minus 3. But now I have to come back here. No. Look. What did I do? I just switched x and y. But I leave it alone. Okay? Any questions? Okay, just for the record, I do have 2 more examples for you. Oh, sorry, let me go back. Thank you for letting me know. Ask me, please. I did. Yeah, you had to do it to both sides. Right, if you do it to one side, you have to do it both sides to keep the equivalency. I think that's a word. Equalness, the same, right? Okay. Are you good? Okay, next example right here. Y equals 4 times the square root of 2x plus 5. How do we find the inverse of a function? Switch x and y. So x equals 4 times the square root of 2y plus 5. And now? So in general now what are we doing? We're solving for y, right? So switch x and y and solve for y. So how am I going to solve for y in this particular problem? I'm eventually going to need to subtract 5, but I definitely can't do that first. I have to do something with the 4. What's the 4 doing to the root sign right now? What's the inverse operation of multiplying? Divide. So I've got to divide by 4 first. What? It is a number that's being multiplied, so to get it away, I have to divide. Yep, it's not really the opposite, because in math, opposite is like 5 and negative 5, 2 and negative 2. It's really the inverse. So 1/4 x equals the square root of 2y plus 5. Did I lose you, or are you still okay? You're going? Okay. Now what? How do I undo a square root? So I need to square both sides? Yes, okay. Square both sides. So what do I get when I square 1/4 x? Close. I have to square everything, right? Not just the x? What's 1/4 times 1/4? Yeah, absolutely. 1/16 x squared equals 2y plus 5. Now what do you want to do? Subtract 5, right? This is what you wanted to do from the beginning, right? But you got to get it out of that, the radical first, right? So I have 1/16 x squared minus 5 equals 2y. I'm going to divide everything by 2. But how can I divide 1/16 by 2? Isn't dividing by 2 the same as multiplying by 1/2? Okay. So if I multiply 1/16 by a half, what do I get? 1/32 x squared minus 5/2. Awesome. Thanks. So now that's all that's left is correct notation, right? We good? Ready to go on? Find the inverse of the function. Well, this is different, isn't it? Well, yeah, there's no reason to freak out about it, though, right? Oh, yeah. Yeah. Is this problem really any different from this problem? It's a list of ordered pairs, isn't it? It's just a list of ordered pairs. If it's a list of ordered pairs, I could just list my ordered pairs, right? -2, -3, -1, -1, 0, 0, 1, 1, and 2, 3. How difficult was that? But tell me how difficult was that? To look at the dots that were there and write them down. Not hard, right? Then how do I find the inverse? Well, this one's weird. If I switch x and y, I get exactly the same. Is that okay? Okay. Oh, this one too. And this one too, right? So how am I going to find the inverse function? Can't I just graph these? Yeah? 1, 2, 3, 1, 2, negative 1, negative 1, 0, 0, 1, 1, 3, 2. Now here's what I want you to think about, okay? When I just switch x and y, just like willy-nilly, kind of switching x and y, what am I saying about x and y? If I can just switch them, aren't I saying they're equal? Guys, look what happens when I graph the line y equals x. It is symmetrical about that line. That's exactly right, okay? The two graphs that I draw are symmetric about the line y equals x. So anytime I give you a graph and ask for the inverse, not only are you going to draw the inverse, but you're also going to draw the line y equals x, because that's your proof, your work, to show that it would reflect across that line, right? Does that make sense? Do you have any questions?